to Fika Bread, and we will sort of start informally, maybe by introducing ourselves. And so I'm Raz. I'm the organizer of this meetup, and we started over a year ago. And the meetup is officially sponsored by the Department of Mathematics for the room bookings and other infrastructure. And then this company called Combiont AB. See, I'm wearing their logo. So I should thank them because they are giving us a lot of infrastructure, including this camera and some Intel nukes we can play with for the next meetup, where we could maybe try and do local on-prem deployments of this Terraform stack. And that's about it. I work in the map department.
Yes, my name is Joe. Master's student now. My name is Lauren, and I study bioinformatics.
Yeah, and say a little bit about what you were planning to get from the meetup.
For me, I'm doing a master's with Rust, so I'm getting into this and want to get a little bit more.
I thought the vendor-agnosticity seems very interesting, this technique. And I'm studying also a cloud computing course at the moment, so it seems very interesting. So I'm hoping to learn more about Terraform.
Hi, I'm Swati. I'm doing a master's in computer science. I just want to know about deployment since I was doing my course in cloud computing in master's research. I just want to know more information.
My name is Divya. I'm studying my master's in computer science as well. And I'm taking cloud computing and big data courses. And I just wanted to expand my knowledge in this subject.
Hi, I'm Punit. I'm a master's student of advanced analytics in Portugal. I just came here for vacations working about this service and the course. And I'm pretty interested in Apache Spark and BPL. That's pretty good.
So Tilo is asking us to speak a bit louder. The audio test. Yeah, it's fine.
Okay, I'm Mahmoud. I took the course throughout the last semester and the semester before as well, so last year. And I've come up here to refresh a little bit and take a little bit knowledge. Because in the course we used back then Databricks, and I think now we'll get a little bit more into the delicate stuff, deeper.
Hi friends, my name is Naresh. I'm doing a master's in computer science. I'm keen on cloud orchestration or automation deployment tools like Terraform or Kubernetes, which is similar kind of frameworks. So I want to explore something new. So that's the reason I'm here.
Hey, I'm Alex. I work as the system administrator at the Uppsala Cloud here.
Okay, cool.
Yeah, and I just came here because it's interesting. This is kind of, we're not using Apache Spark or Terraform for deployment, so maybe we'll start using this after this. So we'll see. Cool. Thanks.
Hi, I'm Oliver. I'm working in a bioinformatics lab over at PMC, and I'd also like to learn some more about Terraform specifically, but big data stuff, cloud stuff.
Hi, I'm Casper. I'm a master's IT student here. I'm also taking the cloud computing course, and I'm looking forward to use this in cloud computing and machine learning. That's my name.
Okay.
All right. Should we start?
You want to say a little bit about yourself?
Yeah, I have a slide. So.
Oh, okay, great. So yeah, we are waiting for this data engineer from Combiont. He's stuck outside the building. Give me 1 minute. I'll grab him.
Okay. Yeah, sure.
so. Just above that. Sit next to the cake.
Maybe you can introduce yourself because we did a round table.
Okay, you just did. My name is Anders Larsson, and I'm working at the SciLife Lab and also within the Farm Bio group, which is where you're partly connected.
Yeah.
And been working with deploying microservices in the cloud. Helped Marco a lot developing.
Yeah, I
some
have a
tools.
slide about
Yeah.
our tool, yes.
Good.
You probably know more than me nowadays.
About that specific.
Yeah.
You're gonna start with introduction.
Yeah, I'm just waiting for.
Okay, so maybe the newcomers can quickly introduce themselves and then we can start.
They have already introduced.
Okay.
I had it. I had
No,
a
you-
live stream.
No, you haven't.
I haven't introduced myself. That's true. I'm Peter Wickland. I'm a PhD student at the math department who's been playing around a bit with Spark. Thank you.
Yeah, and this is
Okay, guys, my name is Alex Gay. I have started here pretty while ago. Now I'm working at Stockholm in some sort of IT company. So I'm sometimes dealing with that stuff, so it'll be interesting just to hear what you're doing.
okay, great.
Right.
Everyone, feel free to have buns and bread.
All right, let's start. I'll introduce myself as well. My name is Marco Capuccini. I'm a PhD student in scientific computing at the IT department here in Uppsala. More or less 1 year left in my PhD studies. And yeah, I'm working a lot on this cloud contextualization stuff, and also we put a lot of energy in having vendor-agnostic solutions because we have collaboration with various institutions. So it's a bit, let's say, annoying to have to deal with different systems and different infrastructure on different providers. So it's nice to have an immutable system that you can deploy everywhere. Before this, I was master student in bioinformatics. And maybe, Alexi, you remember me. You were helping me.
Absolutely.
Alexi was helping me with Hadoop, like when I was starting to learn about this stuff. And before this, I got a bachelor in computer science in my home city in Rome. My interests are mainly cloud computing and data engineering, but also machine learning, or I should say applied machine learning and bioinformatics. So today I'll give you some background on the field. We'll talk a bit about Spark, about Terraform, cloud contextualization, and terminology and tools. Then I'll give you a demo, and then maybe we can play a bit with the technology. So City Cloud has provided us with some credits to play a bit. So we're gonna have. I created accounts for you. So for today we can run on their infrastructure. So how many people in this room are familiar with Apache Spark? All right, Anders, you don't know anything, so I should. I will go very slow through it anyway. Okay, so it's cluster computing engine for large-scale data processing. So we have worked more on Kubernetes together. So that's mostly a solution for large-scale deployments and deploying high available services. This is instead clustering technology for processing data. But there is the same concept of master, worker, and stuff like this. And in my opinion, okay, there are a lot of different frameworks in the big data ecosystem, and most of them are valid, like Flink, and also this newer Ignite is very interesting. But the reason why I personally think we should go for Spark in my lab is because it has really a lot of momentum. So I think it's still the biggest project in big data, the biggest open source project. So you can see there's really a lot of people that want to get stuff in, that are contributing with code, and people saying, "Hey, this is cool. Like I will start this." And for
18,000 people have unstarted.
Unstarted?
No.
No.
Oh yeah, that's right.
Yeah.
You didn't list the number of bug reports.
Yeah. I think that's from my took the screenshot when I logged in. So since I started, I can unstart it.
Yeah.
And yeah, so those are the active questions in Stack Overflow. So if you have a problem, chances are that you're gonna find a solution by searching on Google, right? So, and you can copy paste a lot of stuff while you're developing. So it's sort of nice. I will go very quickly through the API of Spark. So it has a core that is written in Scala. And the reason why they have done this is because the JVM had a very good networking library behind it, and Scala is a functional programming language, so it's a little bit simpler to parallelize Lambda expressions. Then on top of this core, they have an API that is called RDD, that stands for Resilient Distributed Dataset. So this is basically a distributed collection that yeah, you can operate in parallel, and it has a lot of primitives that help you to do some different stuff. So it sort of promotes rapid development, but yes, and of course it's available in Scala, but also Python, R, and Java. But they were not happy enough with this, so they put on top of this even more higher level libraries. So we have Spark SQL that gives us data frames and data sets, and on top of this we can do some SQL and different kind of stuff at high level. Then we have streaming technologies, which if you compare with Flink, is not real streaming. It does mini batches, but it's still quite powerful. And I think they have this Drizzle now, the Rise Lab, that they want to integrate it in Spark, so it will become even more powerful. Then we have machine learning libraries and libraries for graph processing. And these are just some of the environments that you can run Spark on top of. So this is quite good, because if you have invested already in an OpenStack cluster or Amazon, or if you have a Yarn cluster that is up and running, or Mesos, you don't have to buy new machines or reconfigure everything. You can run it on top of your existing stack. And this is because there is a strong community behind this. And perhaps the reason why I really like to use this framework is that it can read really from everywhere. So let's say you have stuff on the object storage on the Snyk cloud. You don't have to explicitly pull it into the cluster. It will be able to pick it from there. And this is very important in big data, because once you have your big data set like hosted somewhere, like, it's expensive to move it. So that's I will spend just a few words about the execution model. So we have a cluster manager, which will be like a master node or a set of master nodes in a high availability settings. And this can be either a standalone Spark cluster, but you can have Kubernetes or Yarn or Mesos. They support really a lot of cluster managers. And then your driver program, which retains the Spark context inside, which is an object that allows you to control the functionalities of your cluster, which will communicate with your cluster manager and with the worker nodes, which will do the actual computations. Inside the worker nodes, you will have executors which are essentially Java JVMs. And instead of this, you will have your tasks running and some cache, cache of your dataset. So let's say you have a very large or moderately large dataset that can fit in your distributed memory. You can cache it so you can access it faster if you have to access it multiple times. So, and this is very important in machine learning because you have these gradient descent methods that work with an iterative model. All right, I guess some of you have worked with Databricks before. So it's this kind of system where you have basically notebooks, which it's pretty much like Jupyter if you have ever worked with it. So you can write some code inside the browser, and you can execute it, and then you're gonna get some rich output out of it. You can do some graphs and stuff. So this will be your driver program to connect to the previous slide, and then this will communicate with the same execution model with your cluster. And Databricks is really nice. It's really a great product, also because it allows you to dynamically allocate Spark clusters on Amazon and recently on Azure as well. So you have an interface, you can create your cluster, you can do some work, and you can release it, and it's pretty much an on-demand solution. So when you have cloud credits, it's gonna be important because you don't want to get to have stuff up and running because you're paying for it. So you just want to have it while you're using it. So can anyone see a problem with this? Come on, don't be shy. There is an obvious.
You are double locked in. You're locked into using Databricks and you're locked into using the services that
Yeah,
they choose to
exactly.
provide.
So there is a vendor lock-in. So we pretty much want to, like for the reasons I was telling you before, we want to move into an open source solution. So the advantages of open source is of course that by definition there shouldn't be vendor lock-in, even though in some cases you can incur in these problems even if you have an open source software. I've seen sometimes. Then of course the most obvious thing that I would think first is that you get free maintainers, so people to develop and test your code for free because maybe they need it for doing something. And therefore the most important thing is that with open source software it's very easy to build a community. But so when we have a Spark cluster or a Kubernetes cluster, like we have essentially infrastructure. So how do we make infrastructure open? And this is where Terraform comes in place, as it has this infrastructure as code paradigm. So basically it defines a DSL that now they are moving to pure JSON in the next version that allows you to define your infrastructure. So network, routers, SSH keys, virtual machines, and so on. and then you can it has this function, so it can do diffs to what you have already running in the cloud and what you have written in your infrastructure as code document. So you can plan, you can see what is going on and what it will be your infrastructure after you apply the modifications to your documents. And finally, it automates the deployment, and you will have it immutable over your infrastructure provider. So you can have it immutable across Azure, Amazon, Google, and the Sneak Cloud even.
It would be a little bit like having Docker Compose, but for
yeah, exactly.
but for cloud.
Yeah, exactly. That's exactly the same concept. And this is also a very solid. It has a very solid community behind. So there are similar things, but I think this is the project that has most contributors. So if you have a problem, you just Google it. Someone has already solved it for you. If you cannot, you can ask Anders. He's very he got very good at this. All right, so now we have our infrastructure defined as code. We can host it on GitHub, so we can make it open. We can have collaborative development, and we can version our infrastructure even. So let's say you are a developer and you want to do some continuous integration. And by the way, are you familiar with the concept of continuous integration? Okay, so I'll go a bit slower on this. So basically what you want to achieve with continuous integration is that every time you do a modification to your code base, you want to integrate it with all of the existing software that you are running, and you want to run a test. You want to run an integration test automatically. So let's say you do a modification to your infrastructure, you push it to GitHub, and then you can have, there is this idea of having a continuous integration system. In this case, this is Redis CI. This is interesting because it's hosted and it has very good integration with GitHub. And this will test your infrastructure on all of the supported cloud provider, or even bare metal if you want. And then finally, if you are on a tagged branch, you can release your infrastructure to the user with the Terraform registry, or you can find other solutions. So, and just to tell you that this is not just stuff that we envision, like we had a project, a moderately large project that was distributed across Europe. So it was a collaboration between 6 universities, I think, around Europe. And we made a large-scale system for medical metabolomics. And the idea with this is that you can go on the browser and you can deploy, pretty similar to Databricks, you can deploy the phenomenal infrastructure on Google or on OpenStack or on Amazon. And then you get access to an app library with tools for medical metabolomics, and you can plug them together with workflow systems such as Galaxy and do some large-scale analysis with it. And we even enable some stuff with Jupyter. And behind this, there was this project that we have developed that is based on Kubernetes. So it's a project to create virtual research environment. This is a little bit more generic than Phenomenal itself. So you can use it to deploy other kind of stuff. But the idea is that you have an infrastructure based on Kubernetes, and then we have some integration with Cloudflare, which will provide some security and some dynamic DNS. And we also provision distributed storage on the fly. And also in this project we had, I would say, quite good feedback from the open source community. I mean, nothing close to Apache Spark, of course. It is a small project, but still, there are people from Red Hat that have clicked start on this, and from other big companies. So, and also a few contributors that I never met in person. So it was quite quite nice.
Does it do something similar to these Kubernetes deployment things like I don't remember, kubectl and this type, or is it?
kubectl is what you use inside once you are inside Kubernetes. So this it's more like how to set up Kubernetes itself, and some other stuff that can be useful if you're doing science on top of this.
It has evolved nowadays, Kubernetes, setting up Kubernetes a little bit, but when we started 2 years ago, it was very...
Yes, I remember playing around with it maybe, what was this, a year ago or something?
Yeah.
And it was interesting.
Yeah.
I like they delegated me to test Kubernetes at work, and then I delegated to so we didn't go forward.
Yeah, but the thing is that, I mean, when we started with Phenomenal, it wasn't even sure that we would use Kubernetes because it was so young. So it was a bit...
All the documentation was like 6 months old, and then didn't work any longer before because the packages have been removed from Ubuntu.
It's problems like this. I mean, but it's the biggest project on microservices, so it will become solid, and it's becoming solid. All right, I will show you a demo. So I've Terraform Spark for you. So that's the
sounds cool.
Yeah, that's the terminology. And I've done this trick with continuous integration, and so it gets, when I do changes, it gets released to the Terraform registry. Today we are gonna use the beta version because I want you to test it so I can release it. And we are going to look into OpenStack. So the idea with OpenStack is that it's pretty much an open source system that you can use in order to build your own cloud. And there are people that are built their own solution on top of it, like City Cloud and T-System. I think Snyk, it runs a quite vanilla version of OpenStack, and then there is Ensemble EBI, which runs a Red Hat branded version. So now I will start to run stuff on City Cloud. So the situation on City Cloud is the following. So we just have a public network, basically. So it will create everything, and while it's creating, I will do this kind of trick that I will make stuff appear in the slides.
What's City Cloud?
It's a public cloud that is based in Sweden, and gives me a very good price. And today we can run for free. So we have $100, so it should be enough.
So City Cloud is also sponsoring today.
Yeah, it's sponsoring. It's. I mean, I didn't have to do much more than creating a free account because it was already enough, and then they bumped a bit. No, but I'm in good contact with them. Like, they're very, very nice. So, and they give 50% off if you are a researcher. So. All right. So obviously, I already have Terraform installed. So now I will give you just a very quick demo, but then during the hands-on session, we will take the time. We will see this process step by step. So what you want to do is to create a directory. I can call it demo. Then inside your demo, you want to create a configuration file. It's called main.tf. And then for this demo, I happen to have a configuration that already works. So I will just copy paste it. So this is already some Terraform code. and it's a superset of JSON, if you are familiar with that. So we will go through this more in detail later, but for now, I just want to pay attention to this external network UUID. So I'm telling it to which public network I want to attach my stuff. Okay, and I will start a cluster with 5 workers.
Should I do data, edge, or candidate install?
It's better to do the stable. I think they're still not stable, so it will be 0.11.8. That's the best. All right. So then, in order to get my module, you do Terraform init, and this will download from the Terraform registry. All right. And then Terraform apply. All right, I forgot to source my credential.
How much of an overlap is there between Terraform and something simple as Ansible?
It's quite different projects, and I would say Ansible it's quite slow. We can discuss a bit this later. Like in this, I will talk a bit here. I'm using Terraform and technologies that was developed by CoreOS, which is called Ignition, and I will talk a little bit about it. So here you can already see like it's planning pretty much what it needs to do, which is creating everything, because now I have nothing on my cloud tenancy. And then I can say yes. And perhaps we can follow what is happening on City Cloud. So if you are familiar with OpenStack, this is a system that was built on top of it, so it's slightly different, but the cool thing is that it gives you the native OpenStack API, so if you have something that works on Snyk, it will work here as well. All right, so it started my nodes, and now it's pretty much waiting for the master node to be ready. So while this is happening, I will tell a bit what's going on. It should take 5 minutes. You just have to pull the required software in the machines. And by the way, you could speed it up a bit with pre-provision images, but I didn't do it yet. So the first thing that you have to do is to create a router and to connect into the public network, right? Then you connect a private network to this router, and you boot the machines. I'm using CoreOS here. If you've never heard about it, like the cool thing about CoreOS is that it doesn't give you anything more than, or very little things more than Docker. So Docker will be the main package manager inside CoreOS. And the reason why I use Docker is that I can create my Spark environment in a Docker container. I can run it on my laptop, test if it works, and then I can move to Terraform once I'm happy. So it's pretty much like a virtual machine, but it doesn't use hypervisor technology, and it builds around Linux namespaces. So it's faster to start. Then on top of this, in the Spark master, I run Zeppelin, which is a notebook that is quite similar to Databricks. So it's an open source version of Databricks. bricks, and then I'm running the Spark master, TensorFlow, and the NVIDIA drivers. So you might ask yourself, but you are using just Docker, how can you install drivers? I found a very interesting blog, and then I implemented. So even the NVIDIA driver is run through Docker.
By the way, in defense of my Databricks-based course, to cater to everybody that took my course, Tilo wrote this library called Pino that automatically babbles Databricks archive notebooks into Zeppelin format. So those of you who are really stubborn could have gone to the right direction. It's in manual edits. But anyway, so anything in my course, for example, has almost functioning Zeppelin notebooks.
Cool. Like maybe I want to use this this library as well. I was looking for something similar actually.
It's supposed to babble into Jupyter too, right?
I just started working on Jupyter and then, so I don't think there's function in Jupyter yet.
Right.
But definitely Zeppelin Databricks back and forth should work.
Then another interesting thing that we do here is to use this ignition. So this pretty much allows me to start each machine with a configuration injected into it, so that it has enough information to start itself independently without having to wait for an external process to tell it what to do. So what you do with Ansible, you have something that runs on your laptop, and then it will tell to all of your machine what to do. So as your cluster increases in size, like it will not scale. Like there are people at Mirantis that like they wait for 2 or 3 days to provision their infrastructure, and in their cases, so it makes sense because it's like they provision it on bare metal, and then it has to be up and running forever. But if you want to do data processing, it's like you can't pay for doing this. Yeah, and we have done. We are also publishing some stuff about the importance of having machines that start and they already know what to do. So we have some experimental results that you can look up if you don't believe me.
It would be similar to, I think Red Hat has something called Bootstrap or something like that.
Yeah, it's might be similar, like or Cloud Init.
Okay. Yeah.
CoreOS Ignition is pretty much like Cloud Init. It's just a bit more high level, and it integrates with Terraform, so I can write everything in Terraform.
You roughly tell it what packages to install. And
yeah, what Docker machines to pull, and then I can tell you format this volume and start in etcd cluster. You can tell quite some stuff. All right, so let's see. I should be almost done. So I think in order, I promised to do some vendor-agnostic stuff. So I should, for you to believe me, I should show you that I can run also on some other system. So here I pretty much have done the same stuff. This is an OpenStack installation that my friends from Humble EBI have provided me. So this is a Red Hat branded cloud provider, and it provides an OpenStack API, so I can run exactly the same thing. And this will fail because I need to source my credentials.
So from there we figure out like.
Yeah, I like the endpoints, and I will go through this during the hands-on session.
By the way, there is no stable install in Ubuntu for Terraform.
But you should download the binary. It's a single binary, so it's quite light. All right, this is taking more than it should, but I have some stuff that kill everything if it failed. So the fact that it's running, it means that. Do you have any questions so far?
Yeah, how do you provision those instances?
So I have Docker images, and when the instance starts through ignition, I tell it through this Docker image and start it, and then I make a system D unit, so I can control it through system D.
Okay, when you say I would like to run 5 instances of this image or whatever it is.
Mm-hmm.
So how does it happen that all those instances will have same configuration?
Yeah, it happens through ignition. So ignition is a JSON specification or a YAML, and you can provide it to the machine. And this tells the machine how to configure itself. So you can tell it, I want to have the following systemd units that they need to start, and inside this you can do Docker run. Then you can say, I want to format this volume. I want to start this thing, like an etcd cluster.
Okay, so for each type of node you have your own recipe, and how this recipe will be delivered to each instance, it's up to this ignition stuff.
Through user data. So user data, so it's something that this is for cloud. So in cloud instances, they have this user data field where you can pass the configuration and it will be run.
Feel free to start eating, guys. You must move around and like a good time to take a break.
Okay, but in general, it acts like a provisioning system like Puppet, Chef, Ansible, right? So
yeah, it's pretty much the same thing, but it's more like I want each machine to start and do its thing without waiting for a node. Because if you are, if you are familiar with Ansible, it's sort of like you have your playbook, and then if you run it from your laptop to an external network that is in London or in the US, it will be very slow because it will open SSH connections and it will coordinate everything. So if you do 10 machine, it's fine. If you do 100, you have to wait a long time.
So are you talking about some whether it's pulling or pushing configuration?
Yeah, exactly.
Because here you're using the same SSH.
Yeah, no, here I'm not using SSH. Here I'm using user data. It's different from SSH. Here I'm using. So user data is it's basically a way to provide an initialization script to a virtual machine.
Which protocol does it use?
In which part?
Which protocol does it use?
Of code?
Which protocol? Which
It's
protocol?
a REST API or something?
It's through REST API. Yes, it's through REST API.
So it's HTTP things.
Yes.
Yeah, so it's it's JSON.
And I guess this is where the vendor specific part comes in, right? So if you want to deploy something OpenStack based, then OpenStack has some REST API.
Yeah, exactly. But the user data. It's provided by it's a standard. It's provided by every cloud provider.
Okay,
then if you want to do.
No, I'm trying to figure out why it's faster, because you have used this SSH thing. You don't use UDP, you use TCP, right? So it's every packet is.
Yeah, but with the SSH session, you still start running things in a shell and you wait for the response.
Exactly, because every machine is independent. There is no central process that coordinates everything. Like each machine starts and it doesn't have to communicate with anything. It will start and it will do its thing without having to.
I mean, SSH does a lot of synchronization because you're sending the command time and you're waiting for the shell.
And plus, it's Python stuff in Ansible, so it's really inefficient. We have a manuscript about this. I can send it to you. But about user data, you can find really a lot of stuff in Google. Like it's considered standard. But we can have this discussion a bit more later, perhaps.
No, but it looks like you have you have some information in text format, and this information is being transformed into image, which is being baked into the instance, and it's like it's done with all the contextualization stuff. Right?
Almost, because the image is a separated thing. So the image is already in the cloud provider. So the machine will start, and then to the image will have a user data.
Okay, I just don't know how it is implemented. Okay.
But I can explain it to you later. I think if we look into the code, it says more than.
In cloud units, we implemented as a virtual disk or something like that will connect, that will be part of the boot.
Yeah, exactly. I think with Ignition, it must do something similar. It's
so
just more. It's just more high level. So now it run. So what we want to do is to run Terraform output. So here we are getting the public IP to the master, so we can reach it, and we get tunneling commands to get to the interfaces. And yeah, that's quite easy way to access something securely.
This is just something you wrote into the script to print.
Yeah, exactly. And what we were doing in Phenomenal, since we didn't want people to open terminals, is that we were using this Cloudflare service that was doing like setting up HTTPS on the fly and yeah, applying some filters for distributed denial of service and similar things. So we were proxying to this through this third party. Okay, but now I'm tunneling, so we can see Zeppelin, and we can see our Spark cluster.
So the other end of the tunnel is now the city cloud, or what is it? Yeah,
now I'm running in City Cloud, which is in this Karlskrona. It's called this city. Karlskrona. Yeah. So it's running there, and I'm tunneling through this IP. And then I'm running a proxy in the master node, so you can see the workers' interfaces as well. Demo. We may, just to see that everything is working, and then we may run an example. That's the pi estimation.
Two correct edges. I've had worse running the example, and I've had that.
All right, and you can access the interfaces. So just for Anders, no problem. Thanks for coming. Just for Anders, because you never work with Spark. So in Kubernetes, we were having this problem of data locality, right? So here I'm parallelizing this list. And then just to show you that Spark is caching stuff, like it's doing stuff in memory, and we have data locality. So you can see that each task like doesn't have like to write to a disk and shuffle stuff through the memory. This is really interesting. This is really convenient, I would say. Then I wanted to show you another thing.
But that was an exchange-free task, right? That example.
Yeah, exactly. I wasn't reading from any.
It didn't have any broad shuffles or anything.
Yeah. Actually, there is one in the beginning. Yeah, but I didn't really have it. But still, it was nice to show that you get this process local thingy. Yeah, because what we have done with Kubernetes, it's nearly impossible to get something like this, even for the Pi example. Like you have to write it somewhere so that the containers will read it up,
Oh, wow.
or you have to invent a REST API yourself in order to send it. So it's quite. I mean, it's in the end we had something that was scaling, but not as good as we wanted.
Marco, there is a module called Spark, and there are worker counts, so it's number of workers not deployed. Could you please show where can I see the which packages will be installed on each worker node?
Yeah, I will.
So how it is?
I think it will be good if we have a discussion after, because I can show you the code actually, so you can see how actually the Terraform code looks like.
So we'll have a post-meetup at the railway station, burger, beer, if you guys want.
All right.
I'll treat you though.
All right, good. So let's say we want to scale the cluster up. Let's say, let's boot 7 nodes. The cool thing about Terraform is that it applies changes incrementally. So here it will figure out that I just want to add 2 extra nodes, so it will not do everything from the beginning. So you can just do like this and do a Terraform apply. And it will again.
So could you please go to the user interface and show number of workers?
Yeah.
So it should be switch from 5 to 7, right?
Yeah, exactly. It will take 10 minutes because they need to provision themselves. But as I told you, if you start for a pre-provision image, it's like takes less than a minute. But I didn't do it yet. So the reason why I'm showing you this is that if someone interested, it can help me in developing this. Like if it's interesting for you as well, you can use it for work then. So I can show you in the meanwhile here that we will have a few nodes popping up. Yeah, and of course, yeah. So now it will tell me I will create this instance and I will create this instance, and it's an instance of type worker.
But these num workers and these variables is something you've defined.
Yeah, it's in my Terraform module.
Yeah.
So we could have another session in which we'll actually learn how to create Terraform modules, and we can can create some subtasks that you could try to develop yourself, or you can come with your own project. I mean, as I told you, I'm interested in further developing this for Spark, so I would be.
Which kind of firewalls are you using for some?
It's
how do you make this environment secure?
Mm-hmm.
So like for example, I want to see that the only ports which are open is which need to be open.
Yeah, exactly. So you can do it with Terraform. You can create a security rule and open just port 22.
Okay.
So I think we can check it in the dashboard maybe. So this Marco sec group. So this is what it created.
Number of groups. Okay.
So it's pretty much okay. Here, that's a bug actually. I should close 443 and 80. So it's good to remember. Yeah, this I copy pasted from Anders stuff where we needed the HTTP and HTTPS. But here I'm pretty much telling that from the outside it can only come TCP 443, 22, and 80. But then I'm not really running anything on this port, so in theory it should be fine. You want to see these two things popping up. I can guarantee that they will, but it will take a while. So we can go on, and I will show you later. So just to conclude this presentation, so the roadmap for my Terraform Spark module is to have support for AWS, Google, and Azure. So the way I work is that if I get credits in one of these platforms and I need to run it there, I will do it because I need it. But of course, I'm interested in developing this. So if you have Amazon credits and you want to run Spark on top of it, and you want to use something that is open source, then I will just help you to do that.
You know, by the way, every Uppsala student has about $200 of Amazon cloud computing credits just from your email address. You know, you should try it. There's some steps you have to follow, and then you'll get the free credits.
So, like, if you want to do an hackathon and do a parting for Amazon, we just do it this way. And it should be quite straightforward because it's Terraform is quite modular. So all of these ignition modules that I created, you can just pull from the registry. You don't have to redefine it from scratch.
So just what is it you have to do, because Terraform already does some of the deployment?
Yeah, very good question, because it's like AWS, Google, and Azure. They don't have any interest in making their stuff
Terraformable.
Yeah, exactly. So Terraform, like even if you work in Terraform, you have to slightly adjust because they offer different APIs.
Okay.
So basically, the JSON, the Terraform JSON for the instance, it will be different when you run on Amazon, because Amazon, it has a different API. You have to specify different things. It's quite easy to do a porting. Like once you have one, and like in a day, if you're already working it, you can do it. Then I want to inject the cloud storage configuration so I can like seamlessly read from the object storage. I wanted to do it with Sneak Cloud, but the object storage is not working. Like today I got this. I wanted to show it today, but I didn't use it in a while, and there was some network issues.
It's being decommissioned.
Okay. All right. So, but I like from the interface, it looks like it's there. Yeah, that was a surprise.
On the other hand, you can just grab it and take it to home. This is commission.
All right. Yeah. Sure. But they are buying new hardware, right? So it will eventually. This is what I heard.
Andreas told me that the new Snyk Cloud is going to have persistent storage. That's why I'm not using the Snyk Cloud yet.
So it won't have object store. It will have persistent storage though. Yeah.
So what is persistent storage then?
So like your volumes will be stored persistently. So you can't. You know how like object store, you attach an object store. Like, it won't have that. It'll just have like actual like your volumes will just be stored.
Yeah, but this is already as block storage.
Yes, so basically we're just expanding block storage.
But can I have concurrent access from multiple machines to the object storage? Yeah, then we cannot run Spark.
Yeah. So I mean, I need to use the persistent storage in different machines to install HDFS or something like that.
Yeah, but that I will do that's my next point. Like I want to implement this. This I will do next week because I really need it to run on the Snyk Cloud, because I want to test stuff before I deploy it on something that I pay. So next week this will be in my module. So when you do Terraform apply, it will seamlessly provision HDFS on top of block storage. So the block storage is working right now, or
yeah, the block storage is going. Yeah. But we're just decommissioning the object store.
All right.
Yeah, at least for UMA. I don't know about C3SC and HPCN2.
Okay, because on Gothenburg there is no object storage, but on there they have, but it's quite there is a lot of there is no machine left, so it's all saturated. I mean, the annoying thing about this is that why I like to use object storage, because it's separated from my cluster, so I can kill my machines and have the data persisting in the cloud. So I mean, if I run on Snyk, it's not a problem because I'm not paying, so who cares?
Write a support ticket, and then that will help us to get more money for.
Yeah. Okay, I will do.
Please.
Yeah.
No, but in principle, you can attach storage from whichever place you want. Right?
Yeah, I could.
You can just mount. Can you just? Or do you allow
You can do
us
it.
to mount S3 buckets?
Why not?
Yeah, you could. Yeah, you could. You could
Because
start.
I have terabytes of data there.
I don't see why not. Like I could even stream the data. Yeah.
It will cost me a lot to.
It will cost me to stream data from the bucket.
Plus there is the delay
all
as
my
well.
data is in Oregon, AWS Oregon zone, so it will cost me for intercontinental bit transfers.
Or I could try to see if we can reattach block storage volume, but I think HDFS gets a bit messed up when you do this kind of thing. So I don't know if I want to invest time in doing that, to be honest.
I mean, you could invest time in, applying it to the bare metal clusters. We have 4 nukes now.
Yeah.
Because
and I'm not sure I have time,
works.
but I can follow someone doing that. It's a bit more challenging on bare metal. We can discuss this. And also, if you have 4 machines, you can set it up manually.
Yeah, we have 7. Same.
7 it starts to be. Maybe you want to.
We can install OpenStack.
But I can provide guidance to whoever. We can make it part of an hackathon. Like I never done bare metal deployments. I never work with.
I mean, that would be cool for next Uppsala Big Data Meetup. From my
we can do an hackathon, and we can try to do it. I never worked with it, but I have an idea on how we could do that. So basically, CoreOS, it gives you a service that is called Matchbox, and then you can pass it this ignition JSONs, and it will start the machine with network boot. So it does some.
This is a bit tricky with the nukes, because there's something with the models. Some of the models we had don't support net booting.
Okay, because they do it through this Pixie.
The ones in his office.
Your ones. The ones you ordered last
year.
Don't support net booting.
And they support netbook, but not net starting. So I forgot what the protocol is called. To start them, to power them on over network.
Yes, but different things.
Yes.
This Pixie booting is different from.
Yes, it supports PXE, but.
Yes, all of them can make Pixie.
Yes, they cannot do this, but
if they can do PXE, it should be possible in theory. I've never tried, but.
No, I don't think all those knocks
I'm sure.
I guarantee that.
Yes, I know they support netboot, but these bare metal provisioning things that I've tried in the past, they all require, for them to work easily, they also need power on.
I understand. Yes, you can do it manually with your hands.
Exactly.
Then I want to do some work in high availability, so multi-node master, and I want my cluster to be able to do security updates and reboot machines while I'm running stuff. So it should be able to reboot one machine at a time. So this is not super. It's not super high priority because I can start every time. Like I do on-demand processing, so I can start from an image that is updated. So. And also, I will not run anything for more than overnight. So there should be low probability of a failure that smash down my cluster, so that it can't be rebooted. Then I will do some work with Big DL and Horowitz for distributed TensorFlow. So this is some research that I'm doing. So I need this stuff. And then an integration with Nextflow. So this is what I do research into. So how to run bioinformatics pipeline with Docker containers. So I want to be able to run this on top of Apache Spark to get data locality. which is what we can do with Kubernetes on its own. Yeah, so now we can start with the hands-on session. Let's see if I can show you that. Yeah, yay. Now there are two more. It's 7. All right, and then yeah, to destroy the cluster, hit the Terraform destroy. Should we take I don't know 10 minutes break before I start?
Yeah.
I think this was going on for an hour or something.
Yeah, and if you people want, we should go. 'Cause last time when we did networking, we were here for 7 hours straight. This is only bad PhDs. So that was painful.
But he's not doing manual networking.
I mean, this should take maybe half an hour if everything goes good. I didn't test this City Cloud account like in parallel with a lot of people doing stuff, so shit can happen.
Yeah, I'm just gonna keep screencasting. So if you say anything, it's all publicly recorded.
I can do this.
But
No,
I can show you the thing.
It's muted, so.
Oh, it's muted?
Yes.
Yeah, so I left 4 Intel Nukes component in my home office.
Okay.
But I have to switch here.
Yeah, but do you want, are we going to do anything with you?
Oh, right, you already found your way.
No, yeah, I was looking just a bit. I even don't know what the language is.
Yeah, exactly. It's this is Cube now. It's another thing. This is much bigger project like we have run for 2 years. So, but if you search for Terraform Spark, we can look into what we have done. And then we did some Ansible as well.
Terraform with some underscore or
Terraform dash OpenStack dash Spark.
It's basically
OpenStack
dash Spark.
like this.
Try to search it on
I was thinking maybe we were actually
one part, it's actually
so
the way he's done it.
I don't think Terraform can do it. It can use
so here I have my modules.
because
So
maybe
these I define.
maybe
Create a lab, I create the ignition
I have no idea.
for my master. So the master will take a JSON
everyone is-
file and want to write
I mean, it's not wrong.
here in this module I create my stuff.
I can imagine
Create my master.
create my
Create my workers.
Yeah, but I think it's
When I create the master, it sort of pulls other dependencies, so it will trigger other stuff, so it will also create the network.
all that recipe nice thing was like the same
But do you specify
Because
some virtual
one
routers here as well?
potential
How would you make this connection?
So if you go up, here I create the network. Yeah. So we can look into the network modules.
and then you can say sanitize instructions.
And
And then once it's
and you can look at main.
somehow privatized,
This is pure Terraform. So this is how we create the network.
So this would be like a really cool USB hard drive. We should put this in a box with just one USB cable.
Import arrangement.
And then we can do
Very interesting.
How much difference between this Terraform and
So how did you hit the mute button on this?
So Rancher is a microservices kind of environment.
the red lamp.
Yeah, it's
so this is not just for microservices, this is for infrastructure in general. So Rancher is a system that you start and then stop. Rancher you run your Docker containers, right? And I think you can start Rancher on pretty much everywhere. The problem that I see with these kind of things is that you have to first start Rancher and then start Spark on top of it, so it's a bit more annoying. So I prefer just to start Spark straight away. I don't want to have a middleware that I don't have.
Okay, and you're using this Terraform, so I just haven't read about it. So can you, using the same recipes, you can deploy on basically virtualized or bare metal environment? Or how?
Kind of. You can see that here it's called the OpenStack. So since the IBIs are slightly different, you have to do a porting. What it will remain the same, though,
I kind of want to get this thing going as well.
is the ignition. The ignition part will remain the same, and you can pull it without refining it. So this is, for example, the master. Yeah, this is actually. I want to show you Spark master.
Because it's so
Yeah, I have very much start from an empty template file, which I do some substitutions, and then create a system view with this
so we have to figure out
file, rendered file.
Because I don't know, have you seen the physical machines? No, I haven't.
Somewhere down in the basement.
It's one big machine.
Here I have my. I guess you have to
Okay.
It's a bunch of machines.
So this will remain
I mean,
exactly the
unless they
same,
do
right?
something very weird, like have one machine with 84 so that for 10 minutes. I mean, that would make it which would make it look.
Or you can tell it to format the volume, or you can tell it to create a file with some configuration.
Okay, but is this still, so I saw that they says cube now and
Last time I
something.
think
So it's a mix of bash,
This project, like, we need
some
one machine is
So cube now, we are using ignition.
it needs to like
We were passing just a batch script to the machine.
He said he's okay.
for example, I don't know, different flavors, Linux flavors, perhaps a bit different versions of
Then we can analyze this
so how often will it break?
I would say almost always like you need to test. Like here I'm supporting only for OS, like having Linux, like a distribution agnostic solution is out of my of what I can maintain during my PhD activity. It starts to become harder. Like these people from from Iran, they have done a very impressive thing. They can support a lot of distributions, but they have a lot of tweaks in their code. That's a major. That would be a major effort to do something like this, and there is very little research value.
So don't you afraid use all those
Weird, annoying. So it's probably even if it's 10 times or 20
basically
times more big
you are
than running it on the mute.
those images
It's probably better to do it on the mute because the other side will have more fiddling.
how
And
do
also
you
the problem
know
is
that
it's reliable. You don't have to
how did you
So
yes, what is the initial image
I mean, I maintain it myself. So I start from TensorFlow.
yeah, I think it's
First of all, inside this field, this is a parameter. There is a parameter field in this alone.
I think it's
But I use one that I start that I built from TensorFlow.
you have 6
That it has the library.
you take some official Docker image.
Yeah, that it has some sanity checks done by Google, so I sort of trust. And then on top of that, I have continuous integration and stuff, so I'm sure
yeah. So I mean,
with the Hadoop version that I want.
yeah.
Okay.
So let's. I mean, we should have a deadline. But I wanted
To see,
let's say,
you're dependent
let's see the vehicles end up running.
on
Yeah.
No, back in Phenomenal.
This internet provider. No, this is
Cloud provider, yes. I can say for now it supports every provider that has an stack dedication. So I can deploy it on Snyk, I can deploy it on Red Hat, I can deploy it on PCs because I mean the OpenStack community has the interest to make something open. But Google and Amazon, they don't have the interest, so they try to avoid it. Because they want to have the vendor locked in, right? So then you have to do a little bit of adjustment.
Okay, why do you use thread as thread is free. First of all, you cannot install two threads. The second, the free account is only for open source stuff, and it
Yeah.
hidden, you have to pay.
Yeah, you don't have to use Travis, but here I'm want to do an open source system.
Why do you use Jenkins, for example?
Because it's not hosted, and I don't want to host it myself. But at least you can do with Jenkins. Like actually, I'm using Travis because I am lazy and I don't want to change stuff that I always done. But people like Circle CI, so this runs the same stuff that I showed before. So it tests on it tests on this Red Hat account that I have. So in the project cluster, it checks that you can reach the UI.
So I think it's some number here. So
and then around Terraform through Docker.
That's how many months? That's if I.
For example, see here is so here. I don't know which okay. Because and which so where is so in order to make I don't know exactly how this Travis works. So does it create how does it pull the source code from here?
It has a web of
container or
yeah, exactly. It clones this project. Then it runs the script that you define in
Okay. So in this script you have to
right.
what to install.
What to install, what will be for the script, and the script that is the test itself. So here I'm doing basically setting up. I'm pretty much doing what I showed you before. And then I check that the workers are as much as I provide. Nothing super advanced. I will probably, as soon as I found some more like bugs, I will have a test for you.
No, I know, but but maybe also to look at it that one day not in this. I don't know what you call from install. They won't go. So this needs some well, it's supposed to be like. So remember the thing is that it's supposed to be something of interest to compensate. Something along these lines. So we want
You wanted the master students in Combio.
No, I want a slave.
Yeah, you want to say that. So anyway, yeah. Jesper says there are others maybe interested because he's the only current official Colombian funded master's student that we have in the pipeline. And I'm supervising him, but I don't want to take more students. They said there are lots of students in IT. If they have an engineering interest, then if you have Alexei's email, just write it in directly to CS.
Yeah, you can send me some slaves as well. I can.
These guys pay, they pay 40,000, 30,000 crowns. So.
Oh wow, that's quite good. Yeah. When I was doing.
Because you need somebody at home.
By the way, do you have a documentation for this project?
Yeah, it's the README for now. Like if you look Cube now, we wrote a lot, but for this project I start with something small, and then if I get people to contribute, I will expand it. So if you look at the README and Google a bit, you can manage to do most stuff, I think. But we'll go through it now. I will go through the README.
It's fine, No, I'm not. So I'm on 125 in case No, I'm on the So I would think
Shall we do this thing?
Sure.
So we.
I can tell you all the Swedish words later.
All right. So if you pick my slides, there is this link. I terraformed Spark for you, which sends you to the Terraform registry.
Is this a download or?
No, it's just some auto-generated documentation. So here you have a README that I wrote with some guidelines. It's not super rich, but if you are able to Google, you will get through this quite easily. And then you have documentation for configurations for this module. Like there are really a lot of things that you can configure, but for today we'll do just basic stuff. So prerequisites are install Terraform. So version, the last one 0.11.8, I guess it's the last one. And then I would recommend to install this OpenStack API. If you have the Python package manager, this pip, then you can install it through it. So it should be sudo pip install. I have to Google for it.
It's also in the package manager.
All right.
Python 3 OpenStack client.
Python OpenStack client. That's how it's called. So please do this. I will wait for you. And
so, everyone installed Terraform?
Yeah. Did you install Terraform already?
No.
No, I haven't.
All right. Then I will. So the simplest way is to download the binary and put it in the path.
Where the zip file? So where is? Oh shit! I have to install pip apparently.
I guess this is boring for you.
Are you gonna is it mainly about setting it up now, or are you gonna run the Spark on Spark?
No, just setting it up. But I will give a presentation about Spark in our group, like more Spark-centric stuff. This was good for you to see the Terraform registry. We didn't do it before.
I have to run that too. And Spark.
How do you install? Apt install Python -pip, I think. Oh, so many words. OpenStack Cyborg, OpenStack Magnet.
Yeah.
Thanks for coming. OpenStack Ballet.
So I'm not the biggest fan of the OpenStack project, but they are the one with most community. So they really have a lot of small things, and it's very hard to configure everything. And plus, it's written in Python, which should be used mostly for machine learning and math stuff, in my opinion.
I'm seeing if I can pip install the OpenStack client.
Yeah, this command should work. So
Where? Ah,
yeah,
Python OpenStack client.
this should be the command.
Yes, thanks.
Or it should be in brew as well. I don't know.
So, and to get pip, do I do apt install?
Python, I think it's called Python-pip in Ubuntu. This is Ubuntu, right?
Yeah. Like this?
Yes. Yes.
In Ubuntu, you may as well try to install this from apt.
It's a type of,
Yeah, I'm installing pip first.
Right. So what is the get it in package and soft. So then you can shape it.
Okay. So do pip install.
Yes. Yes.
So for me, pip still doesn't work.
But why are you using it with sudo?
I don't know.
Just do it pip user install.
Alright, yeah, that's also.
Just user install.
Dash user after install it.
Like this.
Yes.
No, you don't need to just install it.
User after install it. It may also be running with the wrong Python version, so you may
So
need to install
this
Python 3.
client, you just need to like look a bit into OpenStack without having to look in the interface with which.
So probably root is configured to use a different Python version or something.
You actually need, because I didn't create the interface users for you. I just create the
Then I have to
API
go
users.
to, what is this, Terraform? So is this download Terraform by HashiCorp? No. So where will I find the binaries for Terraform?
Where it's
There was a link on the. They gave a link in the instructions. He gave a link in the instructions.
Oh, in your slides, right?
No, you just go to Terraform and you click download. Yeah. Then Mac. Oh, no, you have the
A bit dubious.
No, but they're the same guys who made Vagrant.
Ah, I see.
Yes.
So I just put it in my local software and then point there.
It gives all the documentation is nice.
And then just copy it to
Okay,
user bin.
that's good.
No, that's very nice. You read it and understand. So,
Right.
So the complete opposite of Kubernetes.
most likely, yeah. No,
it will go through this one.
So this import the Koros thing was not relevant now, right?
No, because I already imported it.
Exactly. Yeah.
Okay, so the binary is the zip. Okay.
It's just a single binary inside this.
So it's written in Go, so.
Of course.
And I would like to test it in this way, like try to run OpenStack version. There is no version, but you know. And Terraform version.
Okay. So where your stuff enters is with the first line, where the source equals stuff. So the source equals Capuccini slash Spark slash OpenStack. This is where your stuff gets into the picture. Yeah.
Exactly.
Yes. Yeah.
But before you go forward, I would like to give you more instructions because I need. I mean, we need to pay attention on how we use the resources. So there is another. Is everyone done with this?
How much is this?
Yeah, we have $100. So, but it's also about the.
No, I mean, I have both installed. I have the client installed and I have Terraform installed.
Ah, great. Then it's. But what about the others? Are you done with? Okay, so we can move forward.
The client, the pip install thing.
So next thing is to set up the environment by sourcing the OpenStack RC file for your project. So this you cannot download because I am an administrator and you are not. But if you go on the meetup page, there is a comment with a gist. So this is where Terraform looks to find the endpoints and the credentials. So here you have to create a file with this stuff inside, and you have to source it. But before you source it, you need to put your username, which is your first name, all lowercase, as it's inserted in Meetup. And by first name, I mean the first word. So it might be your surname in reality, I don't know. But I just took the first word to be safe. And then the password, I think I will write it somewhere. I shouldn't.
You write it on the board.
I shouldn't broadcast it, I think.
Start it on the board.
It's just that now I have.
The camera is.
The camera is pointing this way.
Yeah.
So.
It's just that I'm not sure.
Oh. Erase all that.
LA1.
So where are we going into his cube now?
Meetup.
So this is the password.
Terraform.
And this is a dash, a minus, and this is a lowercase u.
Yeah.
So that's, if I remember correctly, this should be.
Yeah.
Lowercase u and uppercase b.
Uppercase u as well.
So where are you seeing this gist thing? So I'm in. Is
So
this where
if you go in the meetup page, I posted it as a comment.
Okay.
It's on the whiteboard. And then it comes the fun part. So we have not enough quotas to run all on the Stockholm region. So I put your names under the region that you will run. So this is Karlskrona, Stockholm, London, Buffalo, Los Angeles, Frankfurt. So please put the string that where your name. So in this way we will not go over quotas.
Right. Okay. I just type the file. Okay. Yeah. So should we give a name to this file that we're editing?
Yeah, like
Credit.sh.
credential or credentials. City Cloud.
Can I run the Terraform in afterwards? Or do you want me to?
Yeah, no, you have to do some stuff first.
Ah, right, just the SSH keys stuff.
Yeah, you're already there. Yeah, wow.
Don't go with this guy, then no one will be able to catch
Where is the gist located?
It's in the meetup page. If you enter into the. Can you see the comments?
Oh, I guess I have to sign in.
Yeah, phone and I get click on the I click on the phone.
I was just thinking to test the password. So if I run it before everyone else gets there, we can make sure that
Exactly. You have to run. You can run. You can search the file.
Yeah.
You put the region as well, right?
Yes.
And then you can run OpenStack.
So just should I, because you have the main TF and the gist. This is the main TF I'm supposed to use.
Yeah.
Yeah.
Maybe you have to fill one thing into it. But if you want to test, you can just run OpenStack. I don't know, in image or maybe network list.
Stack network.
And this is like a tab, but it got a bit messed up.
So what about OS username? So do we...
It's your name in lowercase.
The request you made requires
just my first name. Or it doesn't matter.
All right, then maybe there is a problem.
Let's see. Is this for OpenStack as well, or is this only for?
Right.
Let's do this then.
Yeah, but you need the other stuff.
Yeah,
you
just
source it. You do source.
Yeah, you source it. This is why I ran this, just to make sure. But let's check.
But you source Alf, not Fred. Oh no, Fred still. No?
Name.
Username.
Yeah.
Let's see if I created your user.
So
But
what
the
did
question-
you just use our first names for the username?
No, but it's a bit weird because it's saying the request you made requires authentication. It should
Yeah.
say invalid. Or,
No, but it's very, like, it's very, the error messages are very bad in OpenStack. So.
Okay. Oh. I just accidentally asked for the help, and it's like 400 pages of commands.
Help for what?
For the OpenStack thing. This is just a list of.
Try to switch the lower uppercase.
Good point.
Is it
Now it's taking longer. Yes.
So there is a the password is wrong. It's good
Switch
that
the capital and the lowercase.
Oh. Wait, could you write it a little bit bigger?
Yeah.
I stare at screens far too much in my life.
And what was the region you showed us briefly?
So if you go in G's, in the G's, you're gonna have the region and you are under.
Okay. So it's the ID you need to put there?
Yeah, the main.tf, and then you have to figure out some stuff. Okay? So you have to figure out the class. So the cluster prefix, you can put your name.
Okay.
So it will be the prefix that is given to the machines. And then the public key is this you should know as well.
So it's just my personal public key, or?
Yeah, the public one.
Yeah, just the one I use on a sort of data.
That is already in your keychain.
Yeah.
And so main.tf is another file. We just copy paste this text.
Yeah, and you have to fill it in, and I will show you now how to. So is everyone done with installing, with creating this file and putting the credential in? It should be this. You can call it as you want. It's something that you have to source.
Credentials.txt or
and then you do source that file. Exactly.
Oh, yeah, it's sh is good, yeah.
So sh makes sense.
Yeah.
So you do something like this. I called it CD Cloud. So you just source it. right? And then in order to test, you just run OpenStack. For instance, you can do network list. So you will see that there is a single network. And then they have a lot of subnets, so it's a bit messy, the output.
And it's trying to put a table.
Yeah.
It's expected.
OpenStack
Network list.
network list. Should they make it a bit bigger, maybe?
What if you get R1 must be a class?
What?
Do you
Alright.
do you have to open it as like a file?
Yeah, OpenStack network.
Floating IP pool.
No, wait. That should be just OpenStack network list. So there is some problem with your Python.
And I just installed a new environment. Installed OpenStack.
You're in What's the name?
Perhaps it's the same weird stuff as the original.
We could check maybe it did the.
But it looks like a Python.
Did this have some further instructions?
It looks like a Python version. Okay, go on Google. Or otherwise we ask someone else to.
But we had to add the net UI. Let's see if we can find this GitHub.
But what did you do for? You don't have this cube now. The client is so. Yeah. So then just do KR and OpenStack and for this. Because that one works, right?
Yeah.
Unless you uninstall it.
Floating IP.
No, but that's the Python problem.
Floating IP pool. Let's see where it turns out.
No, without apply. Just OpenStack.
Floating IP.
I see. And then network list.
Okay.
It should be a single combo.
What's that floating IP pool of the OpenStack tenant?
Yeah, that's this cube now. So it wraps around stuff.
Yeah, it's list floating.
Yeah. So basically it runs into a Docker container.
Then you
Okay.
change the password?
Yeah, exactly. So it's switch the lowercase.
Ah, yeah. So you use
Yes. Let's run this command. Maybe we can get a list of IP pools.
So did everyone succeed?
So is he giving us all? Are you giving us all these things we have to fill up in main.tf next?
Yeah, exactly. But now we are gonna figure out the things. So I want to teach you how to use OpenStack to figure out the values.
Floating IP pool? Because apparently they are not available for Compute V2 networks.
Yeah, exactly. So is everyone at this point? So now you have to create a new directory. You create a new directory and then you locate into it. And then once you are into it, you create a main.tf file. Okay, and then you can edit it with whatever you like. And you need to copy paste this inside this empty text file. And by the way, everything I'm saying, it should be documented. So if you don't understand, you just go through this.
I'm also hyper documenting it now. Sonia, just to be.
All right, but you managed to log into City Cloud. Ah no, wait,
no,
that's
I'm
my
just-
screen. Sorry. Yeah, it's a certain time. That would be bad. So once you paste this stuff in your file, I want you to leave this as it is. So this is the source. It tells to Terraform where my Spark module is located in the registry, what is the name of the repository. the version. So we are using beta 1. Cluster prefix. So here you have to put your name. Otherwise, we will have clashes with resources be called the same thing. So put your name in lowercase. Then the path to your public SSH key. You can create one. Do you know how to create a public SSH key? Or you can use an existing one. It's
Otherwise, ask the person next to you, and they can ask the person next to them until they get someone who knows how to do it, and then it will go back.
Are we supposed to like include the extension, or is it just the key itself with
I think it's .pub as well. Yes, if you have the extent. What? Yeah. It's say that it doesn't matter, like as long as it's the full name of the file. But I think .pem is the private. I'm talking about the public. So.
Don't you have one already?
Yeah, just the file name. Exactly.
You just check
and make sure it's the public one, because the private you should not send over the network.
Yeah, but 2 S's in one H.
And then next something fun will start to happen.
Great.
So I'm not giving you the pre-compiled file because I want you to be able to figure this out for Sneak, for instance, if you want to run on Sneak.
We're not supposed to add the use.
Yeah, you are supposed to do it, but I have to.
Okay.
So basically, you run this OpenStack network list, and you will get all of the networks. And in theory, you should see only this public network. It should be called XNet. And you have to take this ID. And then you can paste it in here.
Yeah.
This is external .uid.
Yes.
I missed that.
OpenStack network list.
Okay. Oh, that's this command.
Yeah, so you run here OpenStack network list, or whatever you have the credentials set.
Okay. This one, right?
Yeah, it's easier to type than copy paste, I think.
Yes. Okay.
So I'm not sure that the public is consistent across region. It might be called something else.
No.
Yes? Yes, something?
Credentials.
Alright.
Seeming like this.
Right, because you need the Windows. You should work on Windows as well.
Yeah. So you have the ID on the left.
So you have to install Terraform and OpenStack. So now
the ideal trick it would be to install OpenStack on the new
OpenStack. Then instead
I have never installed OpenStack. What is it? I just opened Spark to complete it.
and then you have to create a file this name of
I was thinking because the code is already available in Terraform for doing it on OpenStack. So it could be possible. I don't know how hard it is to deploy, but it could be worth running OpenStack and just
Why do you need as far as I can understand, this Terraform is orchestration.
Yes.
And OpenStack is also orchestration.
I mean, this is not so much, this is more like a paper app, right? And, I mean, it doesn't do the this is just the recipe, the tool that translates the recipe to something that's
I think
It's
more like
the
Ansible
name
for
of the
REST.
external network.
Oh, okay.
Oh, for
But
external.
Yeah.
More like Ansible, but for REST API.
So next step is the floating IP pool, and that's the name of the external network.
Everything in the network is virtual.
Yeah.
It's created not by regular.
Exactly.
So it will be ext-net, the floating IP pool.
So it's the same?
Yeah, it's the name of the network. So it's in most of OpenStack installation is this way, but in some weird configuration it might be different. So I let the user do it manually.
Okay. But the UID, was that XNet or the ID?
No, it's the ID. And then XNet is the floating IP pool. Then the CoreOS image I already filled it in, but if you are curious, you just can do OpenStack image list, and it will list all of the images that are available. So I think on Sneak there is no OpenStack. CoreOS already available, but you can upload it and then you pick it up in this way. Then this thing I want to check because I'm not sure it's consistent across cloud providers. So I want you to run this across region. So I want you to run this thing. OpenStack image list by grep, and to check if you have this in your region. So this is the kind of machine that you are booting with 2 cores, 4 gigabytes, and 50 gigabytes of ephemeral storage. So this is just to check. All right. So
Is it really image?
It's not.
OpenStack. No. Should be image.
It's image. It's OpenStack image list.
Yeah.
Yes.
And then no, sorry, it's not image. It's flavor list.
Yeah,
sorry.
flavor. Sorry, flavor.
Yeah. So this is the flavor of your instance.
And it's misspelled. Oh, it's an American subject.
So just to check that there is an entry.
So what was the command you did, Marco, before this one?
This one, before this one, I did the image list. Image list.
Okay.
Just to show you how you can see all of the images that are available in the provider. But you don't really need to do this because I already filled it in
And
for
I
you.
don't worry about the floating field.
The floating field.
Network list.
Network list, and it's the name of the external network.
So you have the network list?
Yeah. This one, and then I get.
This is the UID, and this is the name.
It's net. Okay.
What the hell is this?
External network.
So it's more like a job description than a
So the floating IP pool is the second field in that thing, right?
So does everyone have this entry in the output of OpenStack flavor list?
Yeah.
Great. So then that's pretty much it. You can run Terraform init. So please run Terraform init.
Initializing provider plugins. Terraform is successfully initialized.
And then you can run Terraform apply. And it will ask, you will have to type yes into it because it will tell you, I will create this stuff. Are you okay with this?
So Terraform init kind of creates like a state that you want to reach, or
It will pull my module
okay.
from the registry and its dependencies. And then the state is created after apply.
Okay.
So in the beginning it's empty, pretty much.
All right, see you.
Bye, thanks for coming. See you around.
Creation complete after 14 seconds.
So this will, so right now in the directory you just have a text file, right? So what it will do is that it will create a .terraform directory, and inside this there will be my Spark module. So it will pull it from the registry.
So this should still take like 5 minutes, or should it take?
Yeah, 10 minutes more or less.
For like 20 people trying to do things.
Yeah, but we're spread out different regions.
Yeah, yeah. Let's hope
And
it
we're
will.
just starting one each.
Okay, so the grep thing, what is the purpose of that?
Yeah, but I can see that Tilo, Oliver, Alex, you already started.
So what is the point of this grep?
It was just to make sure that you had the flavor existed in your region, in case there were any differences between the regions.
Yeah, because I didn't have time, or I didn't want to check myself.
Yeah. Have you, I'm not working with, have you looked at maps and Juju before? And what are your thoughts about it?
So Juju is the canonical one. It's solid, it's good, but it has less community than Terraform. So I prefer Terraform basically just for that reason. But it's Juju is solid work. Like I have a good opinion about it. Yeah, and Mass.
Mass is a pain.
Yeah, Mass basically it's Metal as a service, right? So that I look into, and there is a Terraform provider, Terraform Mass provider.
So the reason why I'm asking is because we're going to be upgrading the whole cluster here, and we're looking at using maps and Juju together to do it.
If I may suggest, it would be better if I were you. I will do it. I will install CoreOS and use Matchbox with Ignition, because it's I think it's a bit lighter, because Mass Unit it takes some resources, right?
Yes, but resources can find resources. Our issue is right now.
So what is the last thing you do? Terraform init? Have you done? No. Done Terraform init? This is like Git init? For random stuff?
Maybe because you have a Juju thing already made for OpenStack.
We're using Ansible for Ansible.
Alright. I don't know if you have to do it from scratch. I would invest time into use this Matchbox with this. It uses Pixie, and you can make it with Ignition. Like you can define this YAML file. And the cool thing about CoreOS is that you can configure it so it will install automatically the security updates and update the operating system seamlessly, and then you can tell it you are part of a cluster, so make sure to not reboot this image. This instance, don't reboot them all of them together. Or
No such file or directory.
And you can also configure it to have like a window in which is allowed to reboot. But I mean, look into it. Matchbox and Terraform would be another way, and but I mean, if you have something that is already made, if you have a Juju thing that is already made to install, then go for that. If you have the Ansible and it works good, why not continue to work with it?
It's a horrible mess.
All right. Then I would I will try this Matchbox. I think it's nice.
So I have to give the full thing, right? ID RSA.com.
The Ansible OpenStack is fine. I mean, it kind of works, but our issue mainly is there's so much other things that we need to have, like, you know, to start from bare metal. It's like, you know, we need to have our central like DNS maps to give our DHCP and DNS for our servers. We need Cobbler to be able to do Pixie.
External gateway deprecated, use external network ID instead.
So that, like, our issue is trying to streamline that whole process.
Some weird error.
Down, like,
So this is a warning.
just like,
It's error running.
All right.
Oh, I think this is. Did you source?
I mean, I will look into that, because if you use Mass, then it's better if you use Juju, because they are both
I think this was in
canonical.
the other tab.
If he used,
You saw it in this
he
tab, I
decided to go for Matchbox. Then
That's the
there is a
same.
Terraform module that the people from Coro have made.
Okay.
So,
It doesn't like my key.
Do you want to perform these?
I get encrypted key error.
all right, let's see.
Did you also get like cannot open your key?
Yes. Fail to
Do you,
read
do you
key.
have like a special elliptic key or something like fancy?
I have no idea. I created this key like 4
This
years
is a
ago.
private key,
Okay.
so this you should never send over the network.
No, but I'm not sending. I didn't set the private key.
Because it uses, I think it uses the regular expression to
Pub.
find the private.
This is the pub, right?
Ah, yeah, and then it, yeah, exactly. It
Because,
uses,
because I have my key
exactly,
through-
yes.
through
Exactly.
GPG.
So
then
how
we
is
find
your
the
how is your private key called?
Yeah, this, but without the pub.
Okay, that should work then.
But I can try. I have another one. I can try the other one. Maybe this was. Maybe I did something fancy.
Try to do a destroy before the Terraform destroy and then Terraform apply. Maybe you have a passphrase or something. Yeah, because he wants to pick the status from before. So now you start seeing the things that suck in Terraform as well.
This is always the case, right? When you have something that pretends to be mutable. And,
Did you also get like this error? Failed to parse key file.
Yeah, exactly. So
yes.
Yeah.
More or less, at least.
So do you have a passphrase?
This is, I restarted, I think. I made a new key because the key I usually use
Just
is
reading
like elliptic, so it's new.
key.
I think
It's not using the.
so supported in all that open source
All right.
something like that.
Then it might be the case.
So I just made a new agent, right? For,
No, exactly. Because I unlocked it with the agent. So.
Ansible a little bit different. So yeah.
I think the other key is also best. Yes, it is a password protected key, so I guess
All right,
and it's
then,
not using the SSH agent.
Yeah, but I mean, like within Terraform, I could add the option, like I could add an extra field like passphrase if you want.
Or you could use the SSH agent.
Yeah, also. I think it uses the SSH agent already.
At least, because at least not in a good way.
Alright, yeah.
Because for me it's just that this key doesn't exist. Because I'm using it.
Alright, then
I mean, it's finding the key in my case, and I did unlock it with the SSH agent.
but I mean, if you find these kind of things, for instance, you can open an issue in my project, and then we can open an issue in Terraform. Like, they are very, very active. Like, if you tell them we want to do this thing, and they think it's a good idea, they're going to implement it.
Actually, it also means that there's some option for doing it.
Yeah, or they're going to tell you you have to do it this way.
Actually, I should do this because let's see. What's the environment variable for the SSH agent?
Well, that's weird that it worked for me. I personally
no way.
SSH
No, I
off.
get it again.
leave your permission.
Maybe this doesn't get set actually. No, that's correct.
Sometimes these errors are.
Okay, let's try it with the.
How do you like your UI? I like it. Do you use it too for your GPG? I use it for GPT as well. Yeah, when you use GPG like SSH.
So what's going on?
I don't really use it for same. I use it for password. Yeah.
Oh, right, okay.
The one and only password manager.
Alright, so they don't have they don't support it. That's it. We can open an issue on Terraform.
I got it this week.
Yeah.
Okay. Did you get it with the Wire magazine or no? Okay.
Like just make a new key.
I bought two so that if one fails, I still have
I thought I lost my keys. Looks like it's working.
So, people are coming, we want to go and have a thing of hope. You get out of here.
Yeah, sure.
We can't go to the fancy place.
Alright, like if that's a
Fancy place with the bones.
and then I create
there's a chance that the status is going to be wrong because then
on my Unity.
then you
The
can
master
change
key never leaves
So I don't know what's going on. I guess now we are in the city cloud.
It's starting. It's just waiting for the virtual machine or whatever it is to start.
I am if you look outside sea with your English language or your language, I will follow cloud providers. And then if you do it again,
I had a problem because my SSH key is password protected.
Yeah, I figured. Yeah. So what did you do to overcome it?
I created a passwordless SSH key.
But then you
Or rather, I have a passwordless SSH key that I use for my backend. So,
Okay.
yeah, but I have two backups.
I have
Can use the power.
just I have a storage. I'm renting some storage space from.
Then you could like probably
Image recognition. I need to keep it.
well, then you can save it. Then you can do it fine. I mean, you can. If you lose it, then you're fine.
So then I guess we can run a Spark job.
Hopefully, it will happen. Yes. So that's where it would be.
I mean, data locality is basically you have your Hadoop cluster, and each of the Hadoop name nodes are pointing to some hard disks in some machine. And you have your Spark cluster, and you just want them co-located, right? So the Spark drivers, whatever executors are reading from that name node of that Hadoop in the same machine. Is that what?
Sounds like one example.
Is that what data locality and all this means? I don't know what people mean by that.
So I think data locality in general is simply that you want the data, is that something to process the data that it has available to do stuff. Yeah.
Okay. Wow. All right.
So it's the property of the data being in the same place where the computation.
Yeah, so it's just that you have your Hadoop name nodes and you have your Spark nodes, and you want them to be associated to whatever. Because
I think it also, if you do a sequence of
Are you interested in CTF?
you want to, at large extent as possible, that the results are used by the same machine that produces the results. If you have multiple steps.
Because I don't. Yes, I was at the house.
Yeah,
I was there.
Because I was not.
Yeah, I think we're talking about the same thing. So in New Zealand, this is what
Okay, so
we called, at that time it was called co-located clusters. So you have a Hadoop cluster, Spark cluster, we even have Cassandra cluster, and then they all have these different options.
Yes, I know.
Cassandra, some circular
And I don't use Telegram.
These engineers are basically making sure, we
Oh,
call it co-located.
I'm really glad to meet you.
But that's the specific thing if you run different frameworks on the same cluster, right?
It was a bare metal.
One time we were first.
Yes, but that means that you run all the
And then
software on one cluster.
people came in and we were like, oh.
Well, they were deployments of these multiple clusters on the same physical hardware.
Yeah.
Exactly.
So they wanted to
There
make
are
sure.
priorities in life.
But they have locality in general as a general thing.
Yeah, but in this
Well, I
context,
hope we.
I don't know what else it could mean. Because if your Spark say executor, whatever one of the nodes, is running on this whatever machine, it's direct connection to this hard drive, but
You do CTF?
it thinks it's
But for example, say
name
you
node
can.
is somewhere else, then it'll always shuffle. Everything it's thinking it's doing locally, it'll always come from.
But it will catch that. Once
Oh,
it has its results, it's not writing the results back to the original machine.
No, just just reading. Anyway, it doesn't matter. I think I kind of know. It's too abstract otherwise.
No, without the last dot. Because that's
It's just so like random people, and then like there's
Oh,
some
the biggest
more famous
pattern to
ones,
avoid in
like
the Spark tuning thing is not to cache.
DEFCON falls, DEFCON,
Okay.
and then
But it speeded things up by a factor of 2 when I added one cache.
Except if you want to do iterations. Then, okay. But they were talking very more engineering ETL layers. I have all the bit.
maybe next time.
Workshop. My big next worry is to prepare for GLMs. We focus a lot on small files problem, which we don't have.
On what?
If your files are too small in your HDFS, then you get sort of small files problem that
can be the initial bottleneck.
the
So I guess mine is running right. So can you see who's all deployed or?
There is someone who didn't select any prefix, but it worked anyway.
Oh, because there's only one of them. It's probably me.
I don't see Rajesh, so.
Yeah, it's probably me. How do I do that? I don't. There was a key, a variable called prefix.
And it was empty.
I don't really do prefix. Cluster prefix or something. I mean, this is in the shell file, in the main TR.
But it's okay. You can keep it as it is.
Yeah, you cluster prefix. Oh. So as long as you're the only one, it's fine.
Oh, like some people were like.
So the thing that's taking time is pulling all the stuff?
Yeah, put in the Docker image, but you can create an image that
What they sent.
it has already the Docker container in, and then it will basically take less than a minute. The problem with it is that if you have a custom image, then you have to maintain it. So you have to make sure that when you start it, it has like the security updates and the stuff. So it sucks in a different way.
Yeah.
I mean, you can have a script that runs every night and update the image.
Yeah. Sure.
So that's the way.
Exactly. And this, I've used continuous integration stuff once, or for one thing, and this is to generate LaTeX documents from text sources on the Git repository, and I had the same problem there, where every time it had to regenerate, it had to download all of TechLive, which was took like 2 minutes.
But I mean, like, in my opinion, waiting 10 minutes is still okay to have the cluster up and running.
Yes, we get the cluster up and running, but it's more important to get the use the document.
Yeah, then it's a bit. But another way that I was thinking, it's that you can have like a mirror of Docker Hub in your OpenStack, so you can run it and then you can tell it take it from this mirror.
Yeah, or just cache.
Yeah, so the mirror will be a cache basically. So the first time it will take long, and then the next time it's with.
So call my cluster prefix Trump sucks.
We did something like this.
It's on me.
Yeah. But it's fine. You can keep it, run it without. So there is another important thing that I didn't tell you. If you hit Ctrl+C once, Terraform will tell you don't have to do this, otherwise the status will get messed up, and I will not be able to pick it up again. Then if you do it, even though it warns you, it will exit and it will mess up the status. So it's your, it will be your responsibility to fix it yourself. So like, don't do that.
Just delete the state and restart.
Yeah, that's the newbie Terraform user will do this. Oh, shut up! I want to kill this process, and then you figure out that you cannot pick up the status anymore.
So we cannot log into this, can we? The city control panel, because you
no, you would have to create
your own account.
But you can get $100 for you. Like they have like a trial program, so you can get similar access.
What's the smallest? Yeah.
1 core or 1 gigabyte.
For like $5 a month.
That I don't know.
Okay.
That you have to see on their pricing.
Anyway, I've added 8 steps for your gist.
Oh, right.
So now what should I do?
So just refresh it and go to the bottom.
All right. Yes. Great.
So there's 6A, 7, 8.
£160 a month.
160.
But we run some. I ran an analysis on 100 cores. It was quite cheap because we ran it overnight only, so it was less than $100. Like something. I don't know, 400 crowns. But we get 50% off as well. So it's reasonable. The only thing is that they are not so focused on processing. So if you do that, they may contact you and tell you like, hey, I don't want you to run this thing because my customers are getting problems on their websites. So that's the the downside of. But I mean, they want to fix this because they want to get more users, so they will fix it.
Have you tried like that? If Amazon has like a science cloud for this kind of stuff. Have you tried that at all?
Yeah.
Okay.
So we have, yeah, that works good. We have run it for Cube now, the Kubernetes thing.
Yeah.
So that's good. I also like, there is a very impressive cloud that was made by IT System that is like the German communication company. And that one is amazing, like it's super performant and super fast. Like never fail, you never see errors in the interfaces.
What's it called?
It's called T-System Open Telcom Cloud, and Telcom is written the German way with a K. So that I got access through some connections at CERN. So they got founded by CERN in order to build up this thing.
Okay, that usually helps.
Yeah. So did anyone see this success? Oh, great. That's a good sign. So then you just run Terraform output minus module equals Spark, and you get the tunneling command out of it. Now I didn't provision my cluster, so it will not work. So you will get the tunneling commands that you can run in order to see the interfaces. You run destroy before.
No, I've run all of this in a cloud instance.
Oh.
So I have to double tunnel.
Ah, all right. Yeah. Ah, that's not so bad.
Or you just do the same thing.
Yeah.
You change the IP address. Are you trying with City Cloud or Sneak?
No, Upman.
Yeah, it should work. I tried it today.
No. What I mean is, so I started a VM
In Upman, okay.
and then from that VM, I'm starting the Terraform script.
All right.
The City Cloud.
Yeah.
So,
But the same thing you can do on Upmax. I tried it. I mean, I ran it sometime.
The German one is slightly cheaper than City.
Is it slightly cheaper?
Yes.
Okay.
But like 10 crowns cheaper in that third month. So.
Yeah, and also if you are a university, City Cloud gives you like half price. So.
But it looks like their logo, the T is like AT&T logo.
Yeah, it's a bit weird, and you know, like it's Huawei.
It's T-Mobile, it's the same. It's Deutsche Telekom.
Oh, okay.
So it used
But
to be the
it's
public
Huawei
state-owned.
who created that cloud provider. It's Huawei.
Huawei.
Yeah,
Oh.
it's them.
Okay.
So like if you actually send a ticket to them for an issue, they will reply you from China the day after.
Oh, okay.
No, someone
And,
understand that. I think we have.
Oh, like the infrastructure is Huawei. I guess.
Yeah,
Okay.
and they went to Germany and they built it
In Germany.
in Germany, inside the Azure data centers.
Oh, okay.
Yeah, it's a weird. I don't understand what they have done really. I think CERN has given some money to Microsoft as well, so they needed to find an agreement or something. So Microsoft has provided the machines.
Machines, cooling, electricity.
Yeah, perhaps. Yeah, then now you can go.
So I guess once we do this, then we'll have Spark cluster deployed, right?
Yeah, and then once, yeah, you should destroy it before you leave. So I don't have to destroy it manually because I don't have
What is
access.
the command to destroy?
Terraform destroy.
Okay.
Because otherwise I will have to do it manually because I don't have access to your laptop. So.
Should it take more than 15 minutes?
Nope. Then we can keep it running. It might be that there is a problem.
LA.
All right. So we can check what's going on. So you can get a little bit more advanced stuff as well. So, Open a new terminal. And we can check the IP. We can do everything from terminal. So it's more. And then you do OpenStack. Server. Space list. And then grab your name, maybe not. Yeah. Or maybe not, there is only your not so much stuff.
Okay, I got apply complete. The Ross is done. Nice to wait.
It seems like it's a bit slower on that region. They're a bit unlucky. It's taking more than we should. And then you can pick your public IP perhaps from
this. I guess.
Yeah. And then you can do SSH core at. No, you shouldn't get a password. So this you have to add. Yeah, exactly.
Where? Hold on.
The private one.
It's this one.
Yeah.
So can I just do the Zeppelin tunnel?
Yeah. And if you want to look at the Spark interface. All right, you're in the machine. Try to run Docker PS. Alright, so the Spark UI process is started. So what you want to do is the following. So you can do thread journal CTR minus U small.
No, it's system D stuff. I don't know.
Yeah, sorry. System D. System CTL, that's the thing. System CTL status. Spark-master.service. So you see that it's just a very slow network. It's taking long to pull. Which is weird because Docker Hub should be in US, right?
But I don't know.
So they probably have, you have to wait a bit. It will eventually come up.
But pull complete, they're all complete.
No, it's because Docker works that it will print and it will pull different layers, so it's still running. And also that script that runs, it checks if it fails. So if there is a failure, it will just exit and exit with a better status. So this is no problem. This is just a thing that I added to make sure that the Docker container is not already running.
Okay.
If it reboots the machine for any reason. But I instructed systemd to don't care if this fails.
You were also on LA1.
Yes, it's very slow.
Alright, so yeah, you got the bad region, I'm sorry.
Come on. Why did you do this to me? Was it Terraform destroyed or was it? Oh my god.
Yeah, if you are sick of it.
No, I mean, I'm computed 3 digits of type.
Alright. So you can do Terraform destroy.
Oh yes, it's double type.
I don't really understand this.
So I think that eventually I will also create this. I will make a script to create the immutable image.
To just pack it or something.
So it will be packed once, and then what we have done for Phenomenal is that we have a continuous integration that builds it every day. Like it's very was like the guy who made it. Like he have worked for a month only on that because there are so many things that can go wrong.
I can imagine.
And that one is made on top of Ubuntu, so it's even more.
No, it looks good. Yes, creation complete.
Great. So now you have your cluster. So Terraform output.
Started in a few seconds.
Minus module.
Yes, our module
equals
Spark, right.
I didn't even look at what was there. Did you
I already forgot Spark syntax.
Yeah, I always copy paste.
X, comma, Y. What is it? Reduce X plus Y. Yeah. What's wrong today?
That's one of the something that
Yeah, it's a warning. I have to fix that thing. Or you can, if you want, you can send me a pull request.
We'll see.
I wonder if it would be best if you just take one
Okay,
one of the
yes.
people behind listens, like running for example.
So how long have you been running?
17 minutes?
Okay, then it's 3 more minutes.
Oh, you're finished.
So now
Nice. Congratulations.
okay, I changed the main file, added one.
Oh, and I'm guessing you're running off of Amazon.
Okay, so you added two.
And I know the worst part of
So
Amazon
and then you
is
do
on the
But then I made an apply.
Yeah.
And that should be probably networking.
Yeah.
It went to
Yeah, but this
state,
is,
but then I don't see.
Yeah, because it's the machine
one
started, but
billion.
it needs to do the same thing. It needs to install Spark and it needs to connect. So eventually it will.
Okay,
So as I was saying, I can create a custom image, or I can tell you how you can create it. So when it will start, it will have Spark already installed.
But another question is that
Yeah,
now
1 billion is quick too.
Spark
1
that
billion
is-
is that's not bad. 30 seconds, man.
So how do you, in production, probably what you do in production, you don't usually do this.
Oh well, it depends. Like the way.
In
Okay.
science, it's
Yeah, you will do this in production, even in science, right? Because it's if you want to have a Spark cluster that is always up and running, it depends how you use it. So if you have a batch job, then you would do another tunnel or you can expose port 77 on your machine, so then you can send.
So I'm part of
a jar
a
file.
mailing list. Well,
You can do it quite simple.
It's called
I will probably add some documentation about it. It's just that I usually just write stuff into Zapier. So
But
I
then
do
you
it.
close the port, and it doesn't matter. Because
and they do a lot with like transatlantic.
Yeah,
So you close if I close this up, then I have
Fiber
this
freight.
something for running.
Yeah, it's not. It doesn't matter. But the idea with this Terraform stuff, when you use it in the cloud, is that you keep it up and running just for the time that you
Ship
need
has
it.
arrived.
So what I will do usually is that I start Zapier and I write my code that I already tested on a small scale. Yeah, and then Zapier can pull from GitHub even. So I can have my stuff that works on GitHub, I start it, I pull it from GitHub, and then I
So
run it on,
I just have to convince my wife that
then I go that's pretty much what I do. But it would be cool eventually is to have like a Terraform apply that can pick a jar file, send it, execute the stuff, and then auto destroy. So you just use it for the time that you. Yeah.
That's like
Because I just need
100 gigs in general for me is like, oh, that's not.
But why do you need it to be in a pub? Yeah. Because I don't want to be sued for consulting some sensitive thing. And I mean,
No,
it's cheaper.
no one went 20 minutes.
This
Private property.
Is it Terraform only or?
Interesting. Yeah. So.
This one.
So this is great, Marco. 30 seconds to add 1, 2, 3, all the way to 1 billion.
And then yeah, you just take.
Good.
But not the first part. I absolutely did that.
So, I mean, that depends on the machines that they have on CD.
Yeah.
They sort of say that we have better performance than Amazon, so it might be.
But this is one worker, right? This
Yeah.
is one,
Yeah, you have one worker only.
and yeah,
If you want more, you are go in the Terraform file, you increase it.
it's the one we can
L
put
or
whatever.
F
Yeah.
or N. One of no.
I have run it also with 100 cores, and it was working quite well.
I got it. L is the low. The port.
Yeah, I will now. Next week I will put HDFS because I really need it. So
this is what Tilo and I were discussing earlier. So when you say data locality, is this the same as co-locating the Spark cluster with the Hadoop cluster? So the name nodes
yeah,
and the Spark
yeah,
executors
I
are on
will
the
do.
same
I will
physical
do
machine?
that.
Is that what you mean?
Yeah,
Okay.
because otherwise,
Yeah, otherwise, like if you map it incorrectly, then even to read locally, it'll be shuffling through the.
yeah, but it's quite easy. You just need to inject the same host name in the two different JVMs, and it will work.
Because in 2016 New Zealand, I myself did it with some help from, but we took like 3 days and installed Hadoop and then Spark on it, and then Cassandra on it as well. So it was Cassandra Spark Hadoop co-location, because they were using Cassandra key value stores as well to serve, what do you call it, Spark. These are Cassandra adapters for Spark.
Right.
And for some jobs, we really needed Cassandra. Hadoop wasn't fast enough. So all three were co-located.
Like eventually what I could do is that this could become a module for Yarn.
What?
Yarn is this resource manager.
Yeah.
And then on top of Yarn you just run whatever you like, Cassandra or...
That's what these guys did, but you used Yarn for managing the cluster and the little 3-node deployment on my desk.
So I will pretty much, basically for now I just need Spark and TensorFlow, so I'm doing it this way. But little by little I will add stuff.
There's also if you want a fun and very annoying challenge, you can try figuring out some way to run things on our cluster without having root access.
Alright.
You only have access to very old Ubuntu machines running 12.04 without root access.
Then you can do something with this singularity. It's an alternative to Docker that doesn't need root access. Yeah.
Okay, Terraform destroy now.
Yeah, it's just that. I mean, it's you need time to do this stuff, and there's not much research value in it. So it's just tools that I really need for my research. So, and I would like to get some people involved so we can make a very. I mean, this is missing. There is not open source.
I mean, you for one of his applications for master's thesis with me. It'll be great if we can have like a air-gapped deployment on a local on-prem cloud cluster.
Yeah, that would be cool to try.
Yeah, and then ideally after the air-gapped deployment is done and some sanitization is done and privacy is guaranteed, then we would like to use a similar deployment, but on AWS, for example, because we will need to use public clouds for there's a lot of heavy lifting we can't do just on a 7-node Nuke machine. But then the initial ingestion and anonymization it has to be done in a sort of on-prem.
Yeah, we could I could give him some guidance, but he will have to do most of the work.
Yeah.
And, I can double check the code because.
Yeah. I mean, I think tomorrow I'm gonna. So I have the switch, and then I'll just bring the other 4 Intel nukes that Combion loaned me, and that's like full plug and play. We can even take it outside the map department. And,
all right. But we should. We should make it so we have like a meeting, me and him, and we can discuss a bit of stuff, and then he can play a bit, and then he can come and say, "Oh, look what I've done," and then I can.
Because sometimes I get used to
I mean, Tilo is also busy, so. Let me grab. So we're mostly done by wrapping up.
Yeah. We can actually wrap up the session, and so I can stop the streaming, perhaps.
Yeah, you can just stop it.
How do I stop it? Stop streaming.